Hi, Assalamualaikum, and hi guys. Welcome to Electrical Engineering Studies at M Johor Branch, Pasir Gudang campus. Today we are going to learn a subject named Introduction to Engineering with code ETE421. Okay, next slide. Chapter 1, Introduction to Digitalization and Automation. At the end of this chapter, upon completion this chapter, students should be able to define Okay, now let's define the meaning of digitalization. Digitalization refers to the process of converting information, data, or content into a digital format. This involves the use of electronic technology to store, process, and transmit data in a format that can be easily accessed, manipulated, and shared by electronic devices and computer systems. Digitalization is a crucial aspect of the ongoing technological revolution, enabling increased efficiency, accessibility, and automation in many aspects of modern life, including business, education, healthcare, entertainment, and communication. What is digitalization in engineering? It refers to the transformation of physical processes, systems, and data into digital form. This involves the use of digital technologies such as computers, software, sensors, and communication networks to capture, process, analyze, and store engineering-related information. It can encompass various aspects such as data acquisition and sensors, digital twins, computer-aided design, simulation and modeling, data analytics and big data, or Internet of Things, automation and control systems, digital communication and collaboration, maintenance and predictive analytics, and also cybersecurity and data protection. Slide 6, 7, 8, and 9 explain about the various aspects of digitalization in engineering. As you can see in slide 6, it explains about the data acquisition and sensors, digital twins, and computer-aided design. Slide 7, it explains about automation and control systems, data analytics and big data, and Internet of Things or IoT. Slide 8, cybersecurity and data protection, digital communication and collaboration, maintenance and predictive analytics. And slide 9 is simulation and modeling. Now let's move to slide 10, definition of automation. Automation refers to the process of using technology, machinery, or computer systems to perform tasks or processes with minimal human intervention. The goal of automation is to increase efficiency, reduce human error, improve accuracy, and often to accomplish tasks at a speed or scale that would be impractical or impossible for humans alone. Automation can be applied in various fields and industries, including manufacturing, transportation, healthcare, finance, and many more. Automation is a crucial aspect of modern industry and technology. It does not only increase the productivity, but also improves safety, precision, and reliability in various processes. But what is automation in engineering? It refers to the use of technology, control systems, and algorithms to perform tasks or processes with minimal human intervention. The primary goal of automation in engineering is to enhance efficiency, precision, and reliability in various aspects of design, production, operation, and maintenance of systems and processes. Automation in engineering encompasses a wide range of applications and can involve different levels of complexity such as manufacturing automation, process control and instrumentation, robotics and mechatronics, computer-aided design or computer-aided manufacturing systems, and autonomous systems and vehicles. Slide 12, 13, 14, and 15 explains a bit about the applications of automation in engineering. Slide 12, slide 13, slide 14, slide 15 about the applications. Now, let's move to the electronic components. Electronic components are fundamental building blocks used in the creation of electronic circuits and systems. These components perform various functions such as controlling, processing, storing, and transmitting electrical signals. They can be discrete devices like resistors and capacitors or integrated into complex chips like microprocessors and memory modules. One of the main electronic components in engineering is a resistor. So what is the function of resistor? A resistor is a passive electronic component that restricts or limits the flow of electric current in a circuit. It is used to control the amount of current flowing through a circuit and to provide a specific voltage drop across its terminal. The unique of resistor is its color code. It is a system used to identify the value and tolerance of resistors. It has 4 color bands. The first band represents the first digit of the resistance value. The second band represents the second digit of the resistance value. The third band indicates the multiplier or the number of zeros to add after the first 2 digits. And the fourth band represents the tolerance of the resistor. The color code consists of black, brown, red, orange, yellow, green, blue, violet, gray, white, gold for 5% tolerance, silver for 10% tolerance, and there is no color indication for 20% tolerance. The colorful illustration in this slide shows the resistor color codes for your reference. As you can see, there are 4 bands as mentioned earlier. This slide will explain another main electronic components in engineering, which is known as capacitor. What is capacitor? A capacitor is an essential passive electronic component that stores and releases electrical energy in the circuit. It consists of 2 conductive plates separated by an insulating material known as a dielectric. Capacitors have various applications in electronic circuits, ranging from energy storage to filtering and signal coupling. The insulating material between the plates is called the dielectric. It determines the capacitor's value and influences other characteristics of the capacitor. Different dielectric materials have different properties, affecting factors like capacitor stability, maximum voltage, and temperature coefficients. The property that defines a capacitor is its capacitance, measured in farads, capital F. Capacitance represents the ability of a capacitor to store charge. 1 farad is a large unit, so capacitors are typically measured in microfarads or nanofarads or picofarads. How the capacitor works? When a voltage is applied across the plates of a capacitor, it stores electrical energy in the form of an electrostatic field. When the voltage source is removed, the capacitor can discharge, thus releasing the stored energy. There are 5 types of capacitors mentioned here: film capacitors, tantalum capacitors, variable capacitors, electrolytic capacitors, and ceramic capacitors. Another main electronic component in engineering is diode. What is diode and how it works? Diode is a semiconductor device that primarily allows the flow of electric current in one direction while blocking it in the opposite direction. This property makes diodes crucial for various applications in electronics, from rectifying alternating current to voltage regulation and signal demodulation. How it works? It works in 2 states, forward bias and reverse bias. During forward bias, the anode is connected to a higher voltage than the cathode. In this state, the diode conducts current easily, allowing it to pass through. In the reverse bias, it happens when the cathode is at a higher voltage than the anode. In this state, the diode's resistance is extremely high, effectively blocking the flow of the current. There are few applications of the diode, such as rectification, voltage regulation, signal demodulation, switching applications, and protection. What about the types of diodes? How many types of diodes available? There are 6 types of diodes mentioned here. The first one is Schottky diodes. The second one is photodiodes. The third one is variactor diodes. The fourth one is rectifier diodes. The fifth one is light emitting diodes or LED. And the sixth one is xenon diodes. Next is transistor. What is transistor and how it works? A transistor is a semiconductor device that can be used as an amplifier, a switch, or in various other applications in electronic circuits. It is a fundamental building block of modern electronics and is found virtually in every electronic device, from smartphones and computers to televisions and radios. There are 3 main layers in transistor: emitter, base, and collector. The emitter is the layer where electrons flow out. It is the source of current carriers, while the base is the middle layer and controls the flow of current carriers. It is like a gatekeeper. The last one is collector. The collector is where the electrons flow in. It collects the current carriers. There are two types of transistor, NPN type and PNP type. Transistor also works in two states, which are forward bias and reverse bias, just like diode. During forward bias, it happens when the voltage allows current to flow. In an NPN transistor, it means the base is more positive than the emitter. In reverse bias, this is when the voltage prevents current from flowing. In an NPN transistor, it means the base is more negative than the emitter. Transistor can act or operates as an amplifier or also operates as a switch. Last but not least is an inductor, one of the main major electronic components in engineering. What is the function of an inductor? An inductor is a passive electronic component that stores and releases electrical energy in the form of a magnetic field. It is typically made by winding a wire into a coil around a core material, which can be air, iron, or other magnetic materials. The property of an inductor that determines its ability to store energy in a magnetic field is called inductance, denoted by the symbol capital L and measured in henries. The primary component of an inductor is a coil of wire. This wire is often made of copper or another conductive materials. When current flows through the wire, it creates a magnetic field around the coil. The strength of this magnetic field is directly proportional to the amount of current passing through the wire. The inductance of an inductor is determined by factors like the number of turns in the coil, the cross-sectional area, and the type of core material used. Inductors are labeled with their inductance value in henries or subunits like millihenries or microhenries. What is the main key characteristics of an inductor? One of the main key characteristics of an inductor is its opposition to change in current. When the current through an inductor changes, it induces a voltage in the opposite direction, following Faraday's law of electromagnetic induction. How it works? When the current through the inductor increases, the energy is stored in the magnetic field. When the current decreases, the magnetic field collapses and then releases the stored energy back into the circuit. There are few applications for inductor: filter, transformer, inductive load, and energy storage. Okay, with that, thank you guys. I hope you guys can get helpful knowledge from this presentation. All the best and good luck.